Okay, those been watching at home, I apologize. You just missed the most important part of the lecture, but we'll try to get you up to speed. At least you're here now. Okay, how we doing? Shall we take a look? Okay, so what's the vertical intercept? 0, 8. So we come up here, 1, 2, 3, 4, 5, 6, 7, 8. Let's see, do I have a pin? And again, if you've got the grid, it's kind of nice, but we'll just put it there. 0, 8. And then how do I get another point?
4 up, 5 over.
4 up, 5 over. That's what slope tells us. So I go up about 4, and it should be about half of this, right? This is 8, half of it would be about 4. Then I got to go over about 5, which is one more. So I'll just up 4 over 5. Right, so I got 2 points now. How else could I gotten another point?
Down 4 and 5.
I could have put a negative on each of these, so I could have also gone down 4, which would be about halfway there, and back 5. And you'll see these three points are still on the line, and then I can just connect them. Let's make them make the line red. There it is. I'll go this way. Get one nice line. There we go. We've got our sketchable line. So we take the starting point, which is the vertical intercept. It's going to be the number by itself. We take the number in front of the x. That's going to be our slope. And we use the ratio of it to rise and to run. That's it. It gets us a second point. Connect the points. We got our line.
So I'm sorry, if it was a negative, we would have gone down?
Yeah, so if it was like, if the slope had been, say, negative 4/5, then we would have went down 4 and over 5, so it would be going down, right? The way I got this point here, I'll kind of highlight that. I went down negative 4, and then when I go back 5, that's a negative 5. So I still get the same ratio because negative 4 over negative 5 is equal to 4/5, because a negative divided by a negative is positive. This is the one thing you get to do with slope. It's kind of like, it seems like, hey, Little Crow's just making up his own rules now. He's going negative when it says to go positive. But the reason we could do that is because a negative, if I've got a positive slope, it's the same thing as having a negative rise and a negative run. Kind of strange, right? But then if I go from this point, I could also go up 4 and over 5. So I could use basically the same slope. So, because slope is kind of direction. If I'm going forward, it's going to have one sort of signs on it. If I go backwards, it'll have the reverse signs on it.
Oh,
Okay, so yeah, backwards or forwards. So just kind of think, whenever I'm going forward, I'll have one set of signs. So that's going positive. They're both positive. If I'm going backwards, they're both going to be negative. If I'm going forward and one is negative and one is positive, when I go backwards, the other ones, it switches. The negative one is positive and the positive one's negative. So it's kind of like,
okay.
I'm not sure I understand. Yeah, but it'll, and that's what we'll do is we'll practice a little bit as we do it. It's just sometimes it's just an intuitive feeling, but trying to explain it or think about it sometimes is hard to do. Yeah, but it's just kind of, okay, it works. Okay, but we do get a line, and that's all we're going to need to do is take the y-intercept, plot it, and then from that point, use the slope to go up and over or down and back or whatever those instructions tell us to do. Whatever the slope tells us, we follow those instructions. But notice when we use the slope, we don't start from 0, 0. However, when we're trying to find the location of a point, like in this case 0, 8, we did start from 0, 0. We went 0 to the left or right, and then we went up 8. Okay, so when we got a point, we start from 0, 0, go to that point. When we've got a slope, we start from a point on the line, which is usually, in most cases, different from 0, 0, and then we use the slope to get to another point on the line, and another, and another, and another, forever and ever. Amen. Okay. Now, there's a song like that, isn't there? Something like that. I don't know. We just keep going. Okay. Okay. So let's go ahead and pull up some of the. Let's see, where is it? Here it is. So we just pull this up, and we'll look at a few of the examples. And we'll just focus on really the first two tonight. I think that'll be enough to get us started, to get us working with some of these, because that's really, you've got to get that memory part of actually doing it, and then it'll sink in more than explaining. Okay, so again, they start off, they give us this y equals mx plus b. That's what I was talking about, and as you look at it, what you want to think is y and x are going to be variables, so they're going to be part of these equations. The m is the slope. Once you find the slope for a given line, it always will be the same. The b is the vertical intercept, the y-intercept. Oops, b. I'll just put a comma, so x is equal to, it's the place where x equals 0. Okay, right? And then b is the value. They show that it can be written in reverse form. You can sometimes put the b first and then the mx second, especially if you've got a bicycle, right? BMX.
Oh yeah, the bikes.
The bikes, yeah. There we go. Okay. Small joke, but we got to throw something in. Okay. Actually, I had a student, my Math 141, she did a project of the mathematics behind a BMX bike, and I said, great. Because her and her brothers did off-roading and stuff, so it's kind of cool. We can also use function notation, so instead of y, we put f of x. So these are all three really the same thing, just sort of written in a slightly different language. Last one's the language of functions. So it's using function notation. The second one gets used primarily by business. Because it starts with the value and then it has the change, and oftentimes in business, that's, you know where you're starting, you want to know where you're going. So that's what often business uses this form. And math people typically will use the y equals mx plus b. And my best estimation for y is because they didn't really, where did algebra come from? We talked a little bit about this. Does anyone remember?
India?
Mathematics came from India. The world kind of gives algebra its close.
Big geometry.
Algebra. What kind of language is what has a lot of owls in it? It's Arabic. It's Arabic. So Egypt, the Middle East, yeah. So all in there. They did go to India. The Arabs went to India and they did study their math. They got a lot of math from there. But the Arabs were the one who brought algebra up into the European world. Okay. Into Greece and Rome. The Moors, when they took over Spain.
Yeah, right.
So Northern Africa, all of this. So, but algebra. But the key part is focusing on, it was Arabic. Arabs, Arabic language. What do you know about the Arabic language? Maybe nothing, but You know a few cuss words. Okay, that's all, you always learn that. In fact, that's my grandma. That's all she's taught us. Our language is all the cuss words, and it reads in the opposite direction of how we read. So let's see if I get that right. It reads from right to left. So they read backwards. I took a year of Arabic just because I could write with my left hand. I could write Arabic really nice, and then I could write English with my right hand because that's how they taught me. I think I was supposed to be left-handed, but actually I'm kind of ambidextrous. I can use both of them. But it was nice. That's what I liked about Arabic. But so think about it. All the Arab books would have been written from right to left. In Europe, when they went to read these and to transcribe them, they're reading from right to left. So they might have got, in maybe the equations, they didn't really understand. They didn't change the order, but now they're reading them in a different order. Okay. So this could have been how, and again, I'm just making all this up just based on what I think the world should do. So you do the same thing, be some creative thing. But sometimes it's right. I think the Arabs saw it as b plus mx equals y, but now the Europeans are reading it and they see it the other direction, and that's how they teach it. Okay. Business people said, no, that's not right. Let's start and then add to it. So they both work. But sometimes order in mathematics, that's what causes the problems. They mean the same thing. But just be careful. It's not that it's the first number that makes it the slope. It's that it's the number in front of the x. Okay. So I can put the y-intercept first, but it's just the number that's by itself. So look for the x. That will give you the slope. Look for the number that's lonely, and you'll have the vertical intercept. Right? Because it's got nobody else with it. It's got no partner. It's just sitting out there by itself.
What about the third one when it says y equals 2x?
Oh. Well, you don't see it? Let's go through this. Okay. So let's, y equals 3x plus 5. What is our slope?
3.
Slope is always the number in front of the x. So it's 3, or if you want to think of it rise over run, it's 3 over 1. Rise of 3, run of 1. So that's a slope. ID, H, and V.
Decrease.
Oh, thank you. Horizontal or vertical.
Yeah.
So the slope is a positive 3, so what's it going to be doing? It's going to be increasing. Good. It's going to be uphill. Now what's our vertical intercept? The lonely number?
0, 5.
0, 5. Good. So it's a coordinate, 0, 5. 5 is the value of B, but so far so good? Again, here they switch things a little bit on us, but we'll follow along. What's our slope?
-1.
Good. It's the number in front of the x, which there is no number, but there's that invisible 1. So yes, it's -1. And if you want to think of it, it's -1 over 1. -1 over +1. Go down 1 and then run 1. Down 1 and run 1. Down 1 and run 1. So since the slope is negative, what's the line going to? The line's going to be going down. It's going to be decreasing. And what's our vertical intercept? The number by itself, which is there. So it's always going to be 0 for x, and then the y is going to be 8. So far, so good. And again, we don't have to graph it. We're just, we could. Now this is a little bit of a challenging one, but I think some of us might be okay with it. First of all, slope-wise, what's our slope?
2 over 1.
Good. We've got a number in front of the x, so that's 2 over 1. It's positive, so what does that mean about the line itself? It's increasing. How about the vertical intercept? There's an invisible +0 here. It's 0. 0, 0. So yeah, that's the one I'll get you because nothing shows up, but yeah. If something's invisible, it's either 0 or it's 1, depending upon whether it's being added or multiplied. When it's multiplied, the invisibles are 1. When it's added, the invisibles are 0. Okay. Yeah. Because 2x, what's 2x plus 0? 2x. Adding 0 does nothing.
So if the slope is the negative, then it'd be decreasing. If it's positive, it's increasing.
Yes. 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 And again, by doing some of the exercises in lesson 9, and that's why as we get through here, you want to kind of go back, and sometimes it's good to have that's why I sort of recommend only do about half the homework problems the first time through. It leaves you half to go back to and practice some more. Because as we go through this, if you go back and practice on the slope, it'll hopefully make more sense now, and it'll help make this make more sense. Oh, so this one, y equals -8. So we don't say, but this wants slope, increasing, decreasing, and vertical intercept. Which one looks like the easiest one to pick out of here?
Vertical intercept.
Vertical intercept, because it's the number that's by itself, and -8 certainly by itself. It doesn't have an x. So what would you say the vertical intercept is? -8, and you'd be correct. What about the slope? I don't see any x. 1 or 0? Why 0? Because there's nothing there. If it was 1, we would have a plus x, right? But we don't even have the plus x. So what we really have is we have plus 0x, because when we multiply by 0, it turns it into nothing, vaporizes it. And when we add 0, we get nothing more. So you're right. Good. So it's got a 0 slope. And so everything that has a 0 slope, it's a horizontal line, right? It's constant. So this is going to be, draw like this, y equals -8 would be this line down here at -8. So horizontal line. Okay. So get used to that. When we have y equals a number, we have a horizontal line. We'll do a little bit later when we have x equals a number, that's the vertical line. So those are two special cases. They're hard. For that reason, they're kind of hard. You just have to remember. But once you get them down, horizontal lines are always 0 slope. Vertical lines are always what kind of slope? We talked a little bit about it. Undefined slope. Or remember, infinite slope is really, because it's the biggest slope you can get. You can't get any more vertical than vertical. Try to do that and you're falling backwards. Okay, good. Horizontal intercepts. Do you mind if we skip this? And the reason, we'll do one. I don't want to do too much but I would, as you go through this, I would kind of encourage you to skip the horizontal intercepts. They're sort of a distractor. It's not that they're unimportant. It's not that we can do them, but for what we're learning about y equals mx plus b, they are a bit of a distraction. How do we find horizontal intercepts? Y equals 0. So like for this first one, we would plug in 0 for y, 3x plus 5, solve for x, and again, there's nothing, it's not that it's difficult to do, and it's not that it's not worthwhile. It gives us some good practice here. It's just I really want you at the beginning to be focusing on vertical intercepts and slope, and that's it. You start talking too much about horizontal intercepts, or at least what we're doing with lines, it's not really that important. So we get -5 here. This cancels, equals 3x. And then what do? Divide by 3. So we oftentimes, with the horizontal intercepts, end up with some fraction stuff. That's really not it's just not that useful for us. We can do it, and we will do it, and we have done it, but it's right now, it's like, hey, just let me focus on it. It's like, you're watching a movie, right? You don't want to make a decision about what you're going to have for lunch next week. You want to watch the movie. So let's watch the movie. Let's not talk about horizontal intercepts, which are really not important when we're talking about y equals mx plus b, because it's not in the equation. So if you want to, as you go through these, just go ahead and skip all the horizontal intercepts. For now, 2 weeks from now, when we're reviewing for the final, come back and practice with them. But for now, let's just focus on vertical intercepts and slope. Because if you get that understanding, vertical intercept is right on that y-axis, plot it, use the slope to get another point. That's what this is all about. Okay. Okay. We'll skip over that. Draw an accurate graph. So here's again using this. If I can get this to come down. Oh, I can. Cool. So they give us a function at the top. And this is a media example, so there's another video on it, but we'll just go through this. So maybe as we go through here, what's our slope? -3, because that's the number in front of the x. It just is because it is. And we're going to see it works, but sometimes it's just, well, I don't know why, but it is because it is. And you'll see. What's our vertical intercept? 4, because if you plug in 0 for x, that goes away. 4 is all that's left. Vertical intercept's 4, and as a coordinate point, it's 0, 4. So we'll put it that way. Horizontal intercept, yeah, we don't care about that. Okay. Again, you could find it, but it's a lot of times it's a fraction. It's not. I don't care about that because I've got a starting point and I've got my slope. I can get any darn point I want to get. I don't need no stinking horizontal intercept. Okay. Yeah, it's just distracting, right? So, 2 additional points on the line. Again, yes.
So when this is like the function of x, that's the same thing as y. Like it's just
Yes.
they're
Yeah.
just mixing it up.
And I'll tell you, when I was first learning, I would just cross it out and say that's y equals.
Okay.
It is. It's exactly the same thing. That helps you to do it. And then what I do is at the end they want f of x, so then I'd write it in. But it's like learning a foreign language. I would put it in my language that I understood, which is y equals mx plus b. I would figure it out, and then I would translate back into function notation. I did that for years. I got away with it just fine. Always throw away my scratch paper so the teacher never saw what I was doing, but it worked. Okay, so we're going to, where's our starting point? 0, 4, right there. So we go 0, 1, 2, 3, 4. That's our starting point. Slope. Slope is tell us how to get to another point. It's -3. How do we want to think of that slope? There's 2 ways we can think of the slope.
-3 over 1.
-3
Down 3
over 1. And what's the other way we can think of that? +3 over -1, right? The negative's got to switch. And we'll use both of them, and that will give us 2 additional points. Right. So we use this first one. From here, we go down 3, 1, 2, 3, and run 1 in the positive direction, so that's right here. We'll use the other form of the slope, +3 over -1. That means we go up 3, 1, 2, 3, and back 1. So it's a kind of a steep line. So there's our points, but it does look like a line, doesn't it? Again, just get out a ruler or whatever you want to do. Well, we'll keep our line red. And we'll go from, if I can do this point. I really like this software. It's got this line drawing thing. I've never drawn, well, not always perfect, but and then I could draw from here, go through this point. There you go. Sort of like a line. And it works. Okay. Vertical intercept, put a point. Use the slope, up and over or down and back, whatever it says to do, you get another point. And if you use the 2 versions of the slope, you'll get 2 points. And that's really a good way to double check that you're doing everything right. Because if it's not on a line, then something went wrong, which is possible. But this is kind of a cool thing, is thinking that every slope really has 2 versions. It has a forward version, which again, this one gives us the forward. Oops. Here, this is the forward version going that way, and this is sort of the backwards version. Notice that one gave us a point back in time. So just use them both and you get a point on one side, a point on the other, connect them and you got your line. That's all we need. We don't need no horizontal intercepts. We'll talk about them later. In solving problems oftentimes, and notice this horizontal intercept would have been like 1.5. How are we going to put a point there? I mean, you could use it. I'm not saying there's people that do it, but I'm saying for this first part, let's just focus slope, vertical intercept, use it to draw lines, and I guarantee you will understand this deeply, and you'll remember it, and then all this other stuff will make sense later on. Okay. But it's supplementary, it's sideline stuff. The game, it's just like, you gotta, who's a good actor? Like, who's a superstar actor? George Clooney. And who's like the leading lady in the George Clooney movie? Who'd be a good leading lady? Julia Roberts, okay. And some guy like me comes along, you don't want me stealing the show because, you got those guys, right? Little Crow, get out of there. It's not your deal. We got the big stars. Big stars, slope, and Y-intercept. Horizontal intercepts like Little Crow. He's not an actor. He's not a movie star. Get him out of there. Okay, so let's just focus on the big stuff. Okay, so far so good. There's really not much more to this, except we're going to do this analytically, because I'm going to give you a couple points, and from that we'll be able to, we already know, if I give you 2 points, you know how to get slope, right? Rise over, we'll do we'll get some more practice with that. And then I'll show you, having that slope and the point, we'll actually be able to find the vertical intercept. So that's really all that's left to do tonight, is to, if you have just the 2 points analytically without graphing, to come up with that equation of the line. Okay. And then we're all good. We're good to go. Okay, so that was that part. Oh, 2 additional points, we could have figured out what those coordinates were. I think, what was it? Was it 1? I think 1, 1 was one of them, or maybe it was 2, 1, 2 or something, whatever. But 1, 1 and 2, 2. But you could just figure out where those points are and list them. Okay. And again, this is not technically slope-intercept form, but it's close enough. It's intercept-slope form. Okay, so either way. Okay, now let's jump. More problems like this and this. Again, we've done these, so we might come back to it if you want to take a look. What we want to do right now is take a look at these kind of problems. If we can do these 3 problems, these are actually just 2 types of problems, we can do everything we need to do. This is going to be finding the equation of a line. Okay, so what does the equation of a line look like? All right, that's it. That's what we're talking about. When they ever ask for, give the equation of a line, they're looking for y equals mx plus b. Except in 11, they'll change the form on us. But again, by the time we get there, we'll see this, and then we'll see how we can change it to another form. So tonight, we're just talking an equation of a line, y equals mx plus b. So really, our answers are all going to be y equals blank times x plus blank. We just need to fill in these 2 blanks and we're done. That's our answer. That's what our answers look like. Fill in the blanks. So if you want, as you go through here, just do that. So how do we do this? This is our detective's work. Like I told you, you might be this is sort of like the DNA of a line. What do we know about this line? Slope is -9. So, whoa, dude. I can just put that in, can't I? Wow, I got half my answer. It's like 50% credit right now. Didn't have to do much of anything. Does that sound reasonable? So now how do I find this thing? Well, that's a little bit more work. So what I'm going to do, though, is I'm going to do my scratch work over here. I know I've got y equals -9 times x. The thing I don't know, let's go ahead and use b. I don't know what b is. But what's this thing right here? Vertical intercept, right? So what does that mean?
X is 0, 2 must be b.
Okay. So if you don't see that the 2 is just can replace the b, that they actually did give us the vertical intercept, I could have just written in the 2 over here. What I'm going to do, which will help us with the next one, plug in this x for x, plug in this y for y. So the 0 goes in for x, the 2 goes in for y, because that's what it's saying. That point is on the line. So y is 2, x is 0, and we got this plus b thing. What's 0 times negative 9? 0. 2 equals 0 plus b. What's 0 plus b? I don't know what b is, but it's 0 plus b is still b, right? So 2 equals b. Oh, 2 goes here. I'll do it in red as well. Oh shoot, they gave us the vertical intercept. That's what that 2 means. So when I see 0 number, that's my vertical intercept. I could have just plugged it in. This is actually the easiest problem they could have given me. They gave me actually both the answers. They gave me my number that I plug in for the slope. They actually gave me the number to plug in for the vertical intercept as well. Okay, so be careful. When you see a problem like this is really the easy one. They gave you the vertical intercept. They gave you the slope. You're just putting them in their place. You're filling in the blanks. So, seem good? Yeah. But not that exciting. No cheers from the crowd. I know, you must be tired. Okay. No lighters getting lit up. Okay.
You'll get a slow, sarcastic clap.
Okay.
That's what you're gonna get.
Not the golf clap though, right? Okay. Okay. Yes. So now we get to the one that's a little bit harder, and then we're going to do the one that's really hard. But by the time we get there, it's hopefully not too hard. Okay. So this one's a little bit harder. What do we know about this one? Some line that passes through this point and has this slope. What do we start with?
Y equals.
Okay, so y equals, well, something times x plus something, right? And we know the slope. So we know that y equals negative 5x plus b. Now be careful, some people will jump in and get too excited about that because they say, oh, well, I could just plug this 2 in for the b. They'll take this 3 and they'll plug it in for the b. But is the 3, is that the vertical intercept? How do we know that's not the vertical intercept? Because the other number's not, the x is not 0. Okay, it's 2. Okay, so this is not a vertical intercept. So what do we do with this 2? Put it in for the x. What do we do with the 3? Put it in for the y. And this is a place where I would mess up. I oftentimes put the y in for x and the x in for y, and then you get the wrong answer. But doesn't that? So just make sure the x goes in for x and the y goes in for y. It's that simple, but that's what makes it so complicated. Because the x comes first and the y comes second, but over here the y is coming first. And the x comes second. And then it's just do the math, right? And then solve. Negative 5 times 2, negative 10. 3 plus b. How do I get b by itself? Add 10, not 11, 10. Both sides. It's supposed to be a plus. There we go. I'm getting vertically challenged here. I'm sorry about this. Negative 10 and 10 cancel. 3 plus 10. Let's see if I can get it back on level ground here. B equals 13. So again, I can go up here and just fill in my blanks. My slope is negative 5. That's all I need right here. My y-intercept is 13. That's my final answer. Again, our test, when you get to this point, it'll be multiple choice, so you're just circling it. But again, when you do worksheets and stuff, I'll have students that this will be their answer. They'll just leave this, b equals 13. They forget to actually give the equation. So just when they ask for the equation of a line in the future, make sure you give the full equation. Okay, y equals something times x plus b. So far, so good. So I'm going to save this so we have room because, again, this is going to be the hard one. But I'm also going to show you a way that it's really not that hard. It's just more work. There we go. Okay. So we've got a line passing through these 2 points. Now on Monday, we actually graphed the 2 points, and then we could count the rise and the run between the points. So that's what it's all about, because we need both the slope and the vertical intercept. Do we have the slope? Can we find the slope? Yes, that's why we get paid the big bucks, right? So how do we find the slope? We could make a graph. We could use the formula slope equals y2 minus y1 or y1 minus y2. That's either. So if you want to use this formula, Little Crow doesn't really like it, does he? Because I mess it up all the time because of my dyslexia. But the one I do like, so you could do this, we'll come back to it, is you could just take one point. I'll take the bigger point first and put the other point underneath it. And remember, all we got to do is subtract the bottom point from the top. We'll get the difference in the x's and then tuck it underneath the y. So this is the way I like to do it because I don't mess up. Everything's in order because it's an ordered pair, and then I don't have to mess with trying to deal with the formula. So we'll do it both ways, and you see which one you like. So what's 4 minus 2? What's 16 minus 6? Oh yeah, I don't know what I was going to. And then what do we do with this 2? It's the x part, so we put it underneath. There's our slope. What's 10 divided by 2? There's our slope in reduced form. Okay. If you want to use the formula, okay, what's y2? That's 16. What's y1? That's 6, so I'll bring that one over. Oops, 6. On the bottom, what's x2? That's 4. And what's x1? That's 2. Did anyone else just kind of feel like, wow, that was a lot of back and forth? And I could probably mess it up somehow, right? And I tell you what, if there's a way, I've messed it up all the different ways there are. But notice we get 16 minus 6, which is 10, 4 minus 2, which is 2, and 10 divided by 2, which is 5. We get the same answer. I don't know, since I've started doing it this way, and again, it was just in a book I read maybe about 5 or 6 years ago, I started doing that, and I don't make mistakes hardly anymore. Before that, I'd always make mistakes, and when I go to grade a test, I'd have to look at a few tests first to make sure I got the right answer, because I intended, I mean, I know how to do it, but you get in a hurry or whatever, but even me, it doesn't have to be a hurry. It could just be, it's just really difficult to get the things in the right place. So I find if I can do things on a spatial basis, from Vedic math, there it is. Okay. Now we've got the slope, right? Just like with the other problems. So what can we do? 5x plus b. Okay. That's great. Now what do we do? Stop. They didn't give us another point. Oh wait, they gave us 2 points, but which one do I use? I flip a coin or smaller one? You sure? Would it make a difference? I could use a smaller one. I would use it because it's easier to calculate. I could use the bigger one. I could use either one. I will come up with the same answer because both these points are on this line. Okay. And for this particular case, I will use both of them just to prove it to you, because you're going, okay, don't ever say, well, Little Crow said so, so I'll believe it. Don't believe anything I say, because sometimes I'm wrong. I am not infallible. Don't believe anything anyone else says. I don't walk on water. I don't fly through the sky. I do fly on the highways on my motorcycle, but that's about it. I keep it under 90, though. Yeah, most of the time. Yeah, sometimes I'm just in a hurry. And, yeah, it's okay. So what do? Take one of the points, and again, yeah, I think it's a good idea. Take the smaller one; just makes it easier to work with. Plug the x into x. Plug the y into y. So we get 6 equals 5 times 2 plus b. Do the math and solve. Not too bad. 6 equals 10 plus b. We don't divide. What do we do with that to get rid of the 10? Minus it. Yeah, I was going to divide. I don't know why. See, I even when I know what to do, I just kind of I like variety, so I just start doing different things that aren't correct, just because it's more fun to have variety. Boringly, just so that cancels there. 6 minus 10, they're opposite signs. It's 4, and it's going to be a negative 4. That's our b. We're not quite done. We need to write the full equation, so our answer should be something like y equals 5x minus 4. That's it. That's the whole thing. So all we had to do was the extra work was to find the slope. But practice in 9, that's what we were doing, right? We were taking 2 points and finding slope. So that's a thing from 9. The new thing from 10 is take that slope, plug in a point, any point on the line, it doesn't matter which one, and you will find the vertical intercept. And then you've got the two things of that line. That line, that's all there is to a line. There is a slope and there is a height or a starting point measured as the vertical intercept. That's all a line has. Everything else about a line is exactly like every other line. Straight, infinitely long, infinitesimally wide, basically zero width, and it has infinite number of points on it, but this is how we can determine the line. This is all there is to it. The hardest part of a line is that it's so simple, and our experience is that in nature we really don't have lines. Lines are a consistent rate of change. You know, it's like we don't go the same speed all the time on the freeway. I mean, speed limit 65. We should all just 65 all the time, but we don't. We go a little bit faster, maybe more faster, and slower. And some in the times in the morning we're only going 25 because we're backed up, and sometimes we're not even moving. But this experience of a line that's straight and consistent, that's not the real world thing. We don't see that often. But in short periods, lines are very effective tools mathematically for predicting change. In business, they're using straight lines all the time because if you know these two data points, it doesn't so much matter what happened between. If you know sort of a starting and an ending point, if you draw a straight line, it typically will be a good prediction of what happens in the future. Not always. If there's been some change, it's no longer a good predictor. But that's why we use these straight lines. Is I know these two pieces of data. Let's draw the line and let's see what we're going to be tomorrow. And a lot of times, with how things are, it's a pretty good predictor on the short run. Over a year, it's not. A lot of things can change over a year. So, but that's a hard thing about lines. They're very simple, and in the real world, we really don't see straight line stuff. Hardly anything stays the same forever, let alone for a couple weeks, right? Except our salaries, it's a horizontal line, they never go up anymore. Used to be you get at least cost of living. They don't even give that anymore. That's why all those teachers are out there looking for, they haven't even had cost of living, so what does that mean? It's more expensive to live. If we haven't been getting raises, we're actually working the same or maybe harder for less money. It's a hard thing to do, but that's it.
Do we always pick the smallest number?
You can pick either one you want.
460.
You mean here?
Yeah, 460.
Oh, I sort of lied because I said I would do both, and then I was going to stop because I was getting lazy. Good. Let's pick the 416, and I'll show you. I'll get the same answer. Okay. Good. Thank you. But I'll do it in red. And again, you'll see that this is based on this is probably enough to get through the test. But let's take this point. Okay.
That's not going to be in the test.
What's that?
It's going to be in the test.
Oh, sure, there'll be one like this. So you give you 2 points, find it. The other thing, there'll be some questions about parallel and perpendicular lines. That's what I want to put off till Monday, because I want you some practice on this sort of stuff, and I want you to get more comfortable with this just finding the equations, because parallel and perpendicular, again, are very simple concepts, but if we try to do it tonight, we're going to get too much overload and we're going to mess it up. So I don't want you messing it up. I want you getting familiar with this, and then Monday will go very smooth. So again, we take these 2 points. I'm going to, again, what we knew is y equals 5x plus b. I put the 4 in for x, and I'll come up like this. And then I put the 16 in for y, so I come over here. So it's going to be 16 here, 5 times 4 plus b. So we get 16, 5 times 4 is 20, plus b. We subtract 20, subtract 20 from both sides. This cancels. We get b equals, oh my goodness, it's amazing, -4. Same answer. It worked. Okay, so we can use either point because both points are on the line. We use them to get the slope. Could you ever find the equation of a line if I only give you just 1 point? No. Because I gave 1 point. How many lines could there be that go through there? A lot. Infinite. You can't tell. You need 2 points. How many lines can go through 2 points? Exactly 1. The only way to go through 2 points and have more is if you can curve, and you can't with lines. Lines are straight. So if I give you 2 points, there's only 1 that could have done it. As a detective, the evidence is there. Got 2 points. I got a line. There is only one way that can happen. Just find the slope and the y-intercept. Those will be unique things, and that will identify that line. So if I've got 2 points and they're on a line, I can use either one to find that y-intercept. I use both of them to find the slope. I need 2 points to find a slope. Can't even talk about slope unless you have 2 points. 1 point you can't talk about slope. 2 points you can. You find it, and then you use them to find the y-intercept. And that's the end of the story. It's a very short story. The problem is in math they start teaching about, then they get into the horizontal intercepts, and then they'll throw the parallel and perpendicular at you all in the same night. And maybe I should, but because there's all this content because you got to practice. But what I say is let's do less, and we'll do more with less. Have you ever heard that? Because if I give you less information, you can focus on it more clearly. Do a few practice problems, the concepts will be clear, and then you'll be ready. So I think a lot of times is what we do is we give you too much busy work to do, so you're just trying to get through all the work. But if I give you less problems that you reflect on a little bit, I believe it's the reflection that's more important than the amount of work. At least that's how I learn. Just give me 2 or 3 good examples. I'll sit there and I'll stare at it for 2 or 3 hours because that's the way I am. It's relaxing. But you're reflecting on it, you're thinking about it from many different angles, and you'll actually learn it more deeply. At least that's what I think. I don't know, maybe I'm wrong, but I'm wrong. Everyone's wrong sometimes and right sometimes, so just as long as we're right some of the time, that's okay. Anything else you want to see? Let's just see. Let's see where we're at, because I bet you would jump down and there's really not much more to do. Because that's the major part. The main thing is just, now it's just a lot of practice, right? Given the equation of the linear function, that would generate the following table of values. Okay, oh shoot, what I got? Man, they gave me so many points, what am I going to do? I'm freaking out. Calm down, little crow. How many points do we need? 2. Which 2? Any 2, right? And we'll have the line, and once we have that equation, all those other points will be on that same line. So which 2 would you think of using? Okay. 1 and 46 would be a good point. So let's circle that. What would be another good point? We need 2 points, right? We could use any of the other ones, but we need which one? Someone make a commitment. I'm tired of making decisions. I just can't make decisions. -1, perfect, right next to it, because it's not too big. Yeah. So this is another good point.
Or the lowest, that makes a difference.
Yeah, it won't. Well, we could use the -5, 2, 38. It's whatever you feel an affinity for. If you want, oh, 7's my lucky number, let's use the 7. That's fine. And again, what we do is we just come over here. Here's -1. Write it as an ordered pair. 1, 46. And again, we can find the slope. Subtract the top from the bottom. Once we have the slope, plug in one of the points, you get your y-intercept. That's all there is. This is the most complicated thing. They don't give us the slope. They just give us 2 of the points. And again, they gave us more than 2 points here. But so -1 minus 1. How about -2? 110 minus 46. 54? 64. Okay. Probably would have got there eventually. And then we take the x coordinate, tuck it underneath the y coordinate. That's our slope. And this will reduce 64 divided by 2. It's negative. It's 32, right? That's our slope. So then we've got y equals -32 times x plus b. How do we find b? Take one of these points. It doesn't even have to be in these 2 points. It could be any of the points they gave us. But I like smaller numbers, and I like 1. I like multiply. What's that? 1 and 46. That's, yeah. Why make it hard on yourself? The world makes things hard on us. Why should we make it hard on ourselves? I don't know. But we often do. But yeah, just take so 1, and that's supposed to be equal to 46. Do the math. 32 times 1. I love it. I can do that in my head. It's -32. So it's just kind of like I don't really do. And then I add 32 to both sides, right? So add 32. And that gives 8 and 78. So 78 is equal to B. Does that make sense that, so this was 110, 46, so 0's in between here, so the point 0, 78 is also on that line, kind of fits. And then we've got our equation is going to be y equals -32, x plus 78. Okay. So that's all there is really to this lesson. As we go on after this, again, we'll talk about parallel lines and perpendicular lines, but really those things just tell us about the slope, and we'll talk about those. But if we can do this, this is like end run. This is a touchdown. We'll go all the way with just this concept. We get to 12, we're going to find intersection of 2 lines. So we'll be using the equations of the lines to find those intersections. But really everything else after this is an application of this. So far, so good? Okay. Now this one, this looks hard, but we just need its equation, right? We need y equals the slope times x plus the y-intercept. Where do you want to start with this one? What's this point right here? It's 5, yes. It's hard to read, but yeah, it's 5, and it's also called the what? The vertical intercept. So it's the point 0.5. So doesn't the 5 just go here? Isn't that the value of b? It is. Okay. So it's kind of backwards of what we were doing. When we knew what it is, we would plot the point there, and then we'd use the slope to get another point. What we're doing now is from the graph, we're actually reading what the vertical intercept is right from the graph. And then we just need to figure where's another point. How about, oh, there's a nice little point right here. There's one here too. Whichever you see, there's another point. How do I get from this point to that point? I rise 1 and I run 1. So that looks like a slope of 1 over 1. Y equals 1x. So rise 1, run 1. Or -1, -1. However, in rise 1, run 1. We can go this way. There I am. So the slope of 1, and so I could write it just simply as y equals x plus 5. Or 1x. 1x is plenty fine. But you don't need to put the 1. Okay. So when using a graph, we go to the y-intercept, we find that, start with that, and then from that y-intercept, just find another good point on the graph. And what I mean by a good point is where it crosses these hatch marks or whatever they call them, these grid marks. Okay, and you'll see sometimes, depending upon the slope of the line, like a line that maybe went like this, that's not a good point. Oh, there's a good point probably about there, maybe, but so find it where it crosses the grid marks. Okay, and then just count the rise and run. That's all y'all have to do. And I think there's one on the test similar to that where they give you a graph and they ask you to come up with the equation of the line. Simply just look, find the vertical intercept, and then from there use what the slope is to another point. Okay. Yeah.
The one going over 1, with that one going, the line going down to -1?
Oh, so if you see it as going down 1,
No, on the other side. When you did the run.
oh, this one?
The rise, the rise,
Yes.
And then again.
then you go down, would it be a -1?
So for me, so this one,
1, you said 1 over 1. Would
Yes.
it be 1 over -1?
it could be -1 over -1.
Okay.
Yeah. So they would both be negative. So I would go down 1 and back 1.
And then the other way would go back.
Yeah, positive 1 over. Yeah. So yeah, good. And again, this is why you do want to go through and practice with these, because each one's a little bit different and get
Yeah.
enough. But again, don't overdo it, but do spend the time to reflect on what's going on. And remember, it really is very simple because there's only 2 things happening: slope and y-intercept. However, the workbook does tend to throw you off the track with that horizontal intercept. That's why I don't want you doing it. It makes it not, you get too many things, and then simple things just seem like they're not simple anymore because you got me doing 5 things. You're distracting me with the other stuff. So those horizontal intercepts are distractions at this point. We'll come back and there'll be nothing for us. We'll just whip them out. But we've already had practice with them. Focus on slope and the vertical intercept. Writing the equation of the line. And
The parallels will do it next week.
yeah, and then on Monday, we'll finish up whatever's in 10, which is going to talk about parallel and perpendicular lines. And I'll just tell you right now, that gives us some specific information about the slope. But I want to show you why it works, not just show you what it does. And I think that'll make it more memorable. And if you've done all of this homework up to this point, finding the equations of the lines, if you've practiced, say, 10 times at least, you'll be ready. And then when we talk about what we're going to talk about on Monday, it'll make a lot of sense. We'll slip into chapter 11, and we'll be right on track. Because then on Wednesday we'll finish up 11, and I can do 12 in one day. I've got 2 days for it. So just to let you know in advance, the week we do 12, I'll give you a good review on 12. I'll give you a worksheet to do. The Wednesday I'm going to be gone. I'm going to a conference, so I leave in the morning, like 6 in the morning. So I'll be gone. I have a substitute for those of you who want to come, but I've told him you're going to be working on that, and you'll have a worksheet. So if you want to come, and he's good. I just observed him last night. He's one of our newer adjuncts, but he's really good. He's got a strong voice. I wish I had his voice. My voice is so weak, but his has got this booming voice, nice smile, tall guys, nice guy. And he's very knowledgeable about math. And so I think the guy substituted for me before, right? Or was it a girl?
It was a guy.
It was a guy. Same guy. So maybe whatever your impressions of him. Anyway, I liked him. I thought he was good. So he'll be here to help with your problems. But again, I told him he doesn't have to teach anything because you're just going to follow through on what I teach on Monday. And it'll be more time to practice. At that same time, I'm going to give you the practice test for test 3. We come back after that, and we got a whole week to review. We got 2 days to review for that. It's the final exam, but it'll only be 9, 10, 11, and 12. But that's also a good week. What I'm trying to emphasize is if you want to retake any of the tests, that would probably be a good week to do it. And I'd be happy to, we'll work out a deal. We could probably do it in class. You just need to let me know in advance what you want to do. We can do it through the testing center, and then we'll just wrap it up. And I just want to have a nice, solid, successful semester for y'all. Okay, so I'm going to stop recording. Thank you guys for being here.